So we already talked about the three methods of the infinite descent, and there should be more, right? So should be more interesting. Problem that we can use the method of infinite descent. Yeah. So before I start, I hope you guys subscribe to my channel, and my channel is basically contains a lot of physics and math. So yeah, let me just advertise a little bit. Yeah, so you can see that there are a lot of math and physics and other. I mean, math is already from junior high school to high school. Sorry, from junior high school to graduate school. So there are gamma function, there are algebraic topology, maybe some algebraic geometry, and also some Riemann hypothesis, but in the Mandarin version. Okay, so this video, let's talk about another simple one. So there are no non-trivial solutions. I should say integer solution for x squared plus y squared equals to 3z squared. So our requirement is that the x, y, z are called non-trivial integer solution, means that they are both non-zero. Right? So in terms is that they are product are non-zero, so everything is non-zero, and they are integers. And our goal is to prove that there are no such solutions. Okay. I mean this is easy, right? Hope you guys understand. The difficult example is that in my previous video that format that theorem for n equals to 4 case. So the same setting, but now we only deal with the quadratic one. Okay, so it's amazing that even though the quadratic equation is already quadratic Diophantine equation is already so difficult in the number theory, right? So quadratic is very difficult. But this one is not difficult. Okay. So let's prove. Okay, so our idea is using what? Our idea is using so-called infinite descent, right? So infinite descent means that the infinite descent techniques that you prove by contradiction. So by contradiction, suppose there is. So suppose there is solution such that so the solution called x, y, z. Okay. Such that x squared plus y squared equals to 3z squared. Okay, so after you have a solution, then let's do the modulo 3, right? So we divide everything by 3. So we get x squared plus y squared equals to 0 mod 3. And we know that any number, right, if x is 0 mod 3, then its square will be 0 mod 3. If x is 1 mod 3, and the x squared will be 1 mod 3. If x is 2 mod 3, then x squared will be 4 mod 3, right? So, but 4 mod 3 is 1 mod 3. Okay, so in order to you have a two number which is square sum is 0, then only possibility is that x and y are both 0 mod 3. Okay, so that means I can write x. I can write x equals to 3x tilde, y equals to 3, or okay, x equals to x 3x prime, y equals to 3y prime. And I put it back. So I will get x prime squared plus y prime squared times 3 equals to z squared. Okay, but from this 3 is prime, right? So 3 should divide z squared. So 3 should divide z, right? So that means I can write z equals to 3z prime. So I put it back, I get x prime squared plus y prime squared equals to 3z prime squared. Okay, so but by definition, you know that x prime less than x, y prime less than y, z prime less than z. So our infinite descent work, right? Because suppose you can find a solution of the positive integer, then you can find another one. So you can find another one. Then by this method, you can find another one, right? But you know that, so you will construct a smaller integer, right? But there's no such sequence. Because the integer cannot be smaller and smaller. The positive integer cannot be smaller than smaller, right? You cannot have the infinite. You cannot have the infinite sequence which each one is smaller than the previous one. Then all of these are subset of the positive integer. Okay, so which proves that there is no solution. Okay, so this is the simple example, very simple example compared to the Fermat that theorem. for n equals to 4 case. So next example, we will talk about the Olympic problem, which is I guess it's IMO problem, which is very famous that people can use this proof of infinite descent to prove very difficult results. Okay, so see you guys next videos.